Today, we're going to solve two very annoying problems in LTX 2.3. The first one is that the reference image clearly looks great, but the further the video goes, the less the character looks like the reference. The second one is resolution. It's very easy to get stuck around 720p. If we want to push it to higher resolution, most GPUs usually can't handle it. Let's look at the problem first. This is a reference image, and this is the result from LTX 2.3. Pay special attention to the second half. At the beginning, the similarity is still pretty close. But the further it goes, the more obvious that AI look becomes on the face. The skin becomes oily, the cheekbones get wider, the facial muscles become stiff, and the original East Asian facial features start drifting toward a more Western-looking face. If that example isn't clear enough, let's look at a second group. This is the reference image, and this is what the generated video looks like, because this one is a facial close-up as soon as the mouth corners, eyes, or cheekbones deform even a little bit. We can immediately tell that this is not the person from the reference image at all. So the problem we're solving in this video is not whether the image is pretty or not. What we want is for the video to look more natural and more like the reference. Now let's look at the result after using this repair technique. These two videos are clearly much more stable. I'm not saying they are 100% identical, but they are definitely much better than the original version. The face is not as stiff. The character's overall temperament is closer to the reference image, and the output resolution is also higher. The horizontal version is 1920 by 1024, and the vertical version is 1024 by 1920. These are the two key techniques we're covering in this video. Here we'll use an extension. It is not a model, and it is not a LoRa. It is actually a set of custom nodes. The main problems it solves are identity preservation, latent stability, reference image injection, and the quality of the high-resolution upscale stage. Installation is also very simple. Since it doesn't include a model itself, we only need to clone this repository into our FruitySimston nodesci folder and restart ComfyUI. No model download is needed, and no special dependencies need to be installed. For easier demonstration, I also built the workflow on Running Hub in the ComfyUI space. Running Hub is a very solid online workflow platform because whenever a new model or a new extension appears, it follows up right away. Running Hub also provides an online communication platform for ComfyUI creators, where you can find a lot of creative inspiration and example workflows. Next, let's take a quick look at this workflow. It looks like there are quite a lot of nodes, but if we group it by function, it is actually just two stages. It is a two-stage sampling workflow. The first stage is low-resolution generation, and the goal is to generate the original video. The second stage is latent upscaling, and the goal is to make the video clearer. This is not different from the original LTX 2.3 workflow. So why does the normal workflow have problems? The first frame usually has a reference image, but the constraint on the later parts of the video is not strong enough. During sampling, the model fills in frames based on the prompt, noise, and the motion trend. At the beginning, it looks similar, but the further it goes, the easier it is for the model to fall back into the kind of face distribution it is familiar with. That's exactly the problem we just saw. Wider cheekbones, shiny skin, and increasingly stiff facial muscles. At that point, the prompt has very limited control over it. The truly effective method is that we need to turn the reference portrait into a persistent identity anchor at the latent and conditioning levels. So how do we make sure of that? In the first stage, the important node is this one, called LTX Likeness Guide. You can understand it as turning the facial information in the reference image into an identity guide that can be continuously read during sampling. It doesn't just place the reference image on the first frame, it also outputs something called reference info. Then later, an identity anchor continues reading this information and keeps pulling the attention back to our reference character. You don't need to memorize all the parameters here. Just remember 3 points. The first one is anti-silent efferent sever. It lets the reference image participate only in identity preservation, not composition. What we want is the face, not forcing the video to match a certain frame. The second one is BBox Only, which means using only the referenced face region. This reduces interference from the background, clothing, and body pose. The third one is the manual face area. If automatic detection is unstable, we need to manually detect the face region. The second key node is called LTX EMG to video, in place KJ. It is responsible for putting the constraint from our reference image into the latent. This node should also be familiar to many of you. It is provided by KJ. As long as you install the KJNodes extension, you can get this node. You can understand it like this. Likeness guide mainly defines the identity condition, while IMG to video in place mainly defines the starting point of the latent. One lets the model remember this face at the conditioning level. The other lets the latent start from a state related to the reference image. This is why the latent we use here is not an empty latent, but the latent output from the likeness guide. This is also an important method for keeping the character consistent. After the identity constraint is set, we enter the first stage sampling here. There are also two key parts. The first is the generation of the guider. The guider here actually uses a fairly complex process, but we can understand it simply. If likeness guide tells the model who to reference, then this anchor and guider keep reminding the model during sampling. Don't drift too far. The other part is the sigma's easing node. This node mainly adjusts the rhythm of how the sampling noise decreases. You'll notice that the official workflow even tells you not to change this part casually, which means this node has been carefully tuned. At this point, the first stage is complete. In the second stage, we mainly solve the high-resolution upscale problem. Normal LTX 2.3 has a hard time going directly to high resolution. The key is that here we use a special node called LTX Latent Upscaler Tiled. It uses tiled mode first. Make this clear. It is not upscaling the video in pixel space. It is upscaling the video in latent space. It also uses a tile mechanism, which means we cut the latent into many small blocks, process each small block separately, and then stitch them back together with overlapping blending. There are two benefits. First, it saves VRAM. Second, it is more stable for vertical videos, large sizes, and extreme aspect ratios. This is why the repaired videos you see can reach 1920 by 1024 or 1024 by 1920 instead of the traditional 1280 by 720. After this upscale, we still need to run sampling once. Here we also use tiled sampler. This is a sampler that also supports tiled mode. As an optimization mode, it will not heavily rewrite the character's identity, and it will not completely overturn the motion structure. It tries to preserve the consistency of the character and the action. Now let's compare again. This is the first group. This is the result from normal generation. The main problem with the normal version appears in the second half, where it increasingly looks like the model's default AI face. After the repair, the face is not as stiff, and the facial features are also more consistent with the reference image. The second one has the same problem. This is a close-up, so the comparison is even more obvious. In the normal version, the expression muscles easily become stiff. The repaired version still has some traces of AI video, but overall, I think the face shape and temperament are already much better. Next, let's briefly summarize. If you want to reproduce this workflow, follow this order. First, install the extension. Second, prepare the main model. Let me emphasize this. For both the main model and the upscale model, try to use version 1.1. Don't use version 1.0. Version 1.1 gives a much more obvious improvement. Third, use the default parameters as much as possible to get the whole workflow running first. There are few parts you should not change, especially the sigmas. This video mainly solves two problems. The first is that the second half of an LTX 2.3 video becomes less and less like the reference. The second is high-resolution upscaling. I think both of these problems are very important. So what are you waiting for? Go try it yourself, follow me, and become someone who truly understands AI.